This is the Introduction to Advanced Algebra 2. I'm Mr. Stark. We're on topic 4, linear equations and their graphs, which means we're about halfway through the unit, which means we could finally talk about that Yox in the top left corner. He's been waiting to come down this whole time. We'll learn about slope and equations of lines, and you could follow along using this document. So let's get linear. If we're talking about linear equations, we have to talk about the concept of slope. And the concept of slope is fairly straightforward. It's the ratio of increments, or it could be seen as rise over run. In a moment, we'll look at the street map of the northwest side of Chicago so we can understand the concept of slope. But before we do that, I want to make sure that you understand the idea of an increment. There are two of them. One of them is delta y, which is equal to y2 minus y1, or the difference of two y values. The other one is delta x, which equals x2 minus x1, or the difference in two x values. In math, the Greek symbol delta means change. And when we're talking about lines, delta y is the change in the y value, or the rise. And delta x is the change in the x values, which we call run. And again, slope is just a ratio. It's the ratio of the increments, delta y over delta x, or the ratio of rise over run. Just like the bullet points say, we'll be using a city map with a perpendicular street grid. I chose Chicago. We'll see how rise can be represented by the north-south difference, and run could be represented using east-west difference. Let's take a look. Here is a map of the northwest side of Chicago. You can see some of Interstate 290 at the bottom of the screen, which basically separates the north side of Chicago and the south side of Chicago. All that blue stuff is a lake. I hope you know which great lake it is. Lake Michigan. On the bottom right, you could see two large landmarks, Navy Pier and Buckingham Fountain. Further up the coast of Lake Michigan, you could see Lincoln Park, where there's a Lincoln Park Zoo. So great, so unique. It's like right inside the city. And there's historic Wrigley Field, home of the Chicago Cubs. If we travel west on Irving Park Road, we'll end up in Portage Park, which is the neighborhood where I grew up. I used to walk to the Portage Park pool in the summer, where they had a 5-meter platform and a 10-meter platform that you could dive or jump off of. Pretty crazy and scary. So let's get back to the math and try to understand rise over run from this map. Let's say I wanted to travel from the Portage Park area to Navy Pier. We could rent some bikes and ride along the lakeshore, or go to the Shakespeare Theater, or all sorts of fun stuff. We could find the rise by starting at Portage Park and moving straight south. And what I'm going to do is count in these squares here, because it's basically like a square mile, plus or minus. So I'll just kind of assume that I'm at this street here. So I go 1, 2, 3, 4, 5, 6, 7, 8, maybe one more, 9. So the rise, and it's a little above that, yeah, if we kind of go across, the rise is -9. And the rise could be positive or negative. It just depends on which way you're going. Now we'll do the run. So we'll move to the left or right. Obviously, we need to go to the right. So I'll stay in the middle of these squares. And I'll go 1, 2, 3, it's getting tricky, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, ooh, okay, fine, let's say 14. So the run is 14, and since we're moving to the right, it's a positive value. Okay, fine, it wasn't perfect. Give me a break. But what's cool is we could do a variety of things with that information. We could find the slope by writing those numbers as a ratio. We could estimate the distance from Portage Park to Navy Pier by sketching a triangle and using those values that we just found to find the hypotenuse of that triangle. And we could also estimate the midpoint of our route. Okay, well that's all for the northwest side of Chicago. You should visit sometime. They have really great museums. Now that we understand the concept of slope, let's actually calculate slope. The example says to find the slope of the line containing 3, -2, and 0, 1. And remember, a line is defined by 2 points. Remember, slope is the ratio of delta y over delta x. And the official formula is y2 minus y1 divided by x2 minus x1. The y values are always on top, the x values are always on the bottom. Y over x. That's why the yox is in the top left of the screen. Let's take the second y value, which is 1, and subtract the first y value, which is -2. 1 minus -2. Divided by the second x value, which is 0, minus the first x value, which is 3. 0 minus 3. Therefore, we have 3 divided by -3, which is -1. -1 is the slope of the line that contains those 2 points. I have 2 more thoughts to share with you. The first one is parallel lines have the same slope. And the second one is perpendicular lines have slopes that are opposite and reciprocal. So if line 1 had a slope of 2, which is the same as 2 over 1, and line 2 was perpendicular to line 1, then line 2 would have a slope of -1/2. It's opposite, meaning the negative version of it, and reciprocal, which is the fraction flipped upside down. One other way to think of perpendicular lines is the product of their slopes is -1. I have a brief thought regarding the concept of equations of lines. There are 2 methods to determine a line. Jot these down. The first one is you could determine a line with 2 points. Meaning if you plot 2 points and connect them with a line segment, then you could extend that into infinity, and that would represent the line. The second method is with a point and a slope. And that means first you plot a point, then you use the slope to plot the next point. So rise over run, you go up or down, whatever that increment is, and then you go left or right for whatever the x increment is. Finally, writing equations of lines. We can do it in 3 ways: point slope, slope intercept, or general. The formula for point slope is y minus y1 equals m times x minus x1. We should primarily use this formula. There are a few reasons for that. If you solve for y, you could get the slope-intercept form. And in calculus, when you write the point-slope form, you're able to look at the equation and see, at a specific point, the slope of a curve is what's written. And when we write the equation, we plug in for y1, m, and x1. From our example earlier, we had the point 3, -2, and we found that the slope was -1. We could write the point-slope form of the equation as y minus -2 equals -1 times x minus 3. And we could simplify the left side of the equation to say y plus 2, but we should just leave it as is unless we're told to solve for y. The formula for slope-intercept is y equals mx plus b. M is the slope, and b is the y-intercept. The y-intercept is the point at which the line crosses the y-axis, so that point is 0, b. Let's solve that point-slope equation we were just working with. On the left side we have y plus 2, and now we could distribute the negative to the right side, -x plus 3. So then we could subtract the 2, and we get y equals -x plus 1. Hey, that makes a lot of sense, because the other point was 0, 1. In this equation, we could see that the y-intercept is 1, or if we plug in 0 for x, we get 1. The formula for the general form of a linear equation is ax plus by plus c is equal to 0. Officially, A and B cannot be 0, otherwise we don't have a line. But if A is 0 or B is 0, meaning just one of them, then we either have a horizontal or vertical line. Also, when we write the equation, A should be positive. So if we end up with an A value that's negative, we should add AX to both sides of the equation. And just so you know, X equals A is a vertical line, and Y equals B is a horizontal line. Now let's take that slope-intercept equation and make it into a general equation. Since X is negative, we should add X to both sides. And since the form of the equation has everything on one side, we should subtract 1 on both sides. That leaves us with X plus Y minus 1 equals 0. Also, one more thing. Sorry, we want to avoid letting A and B be fractions. So if one or both of them are fractions, simply multiply by a number that will result in integer values for A and B. That's it for linear equations and their graphs. In the next lesson, we'll learn more about parallel and perpendicular lines. I think you'll like it. We'll be using the graphing calculator. Thanks for watching. See you next time, and go Cubs.